Hi, as promised, I'm going to make you guys a video that sort of shows me working the examples from today's lesson. So today we're learning about converting using the mole. And so the first type of example we're going to talk about are how to figure out the number of atoms or molecules from moles. And so the conversion factor that we use for this is that 1 mole equals 6.02 times 10 to the 23rd atoms or particles. And this is what we're going to be using as our conversion. And so remember that since 1 mole is equal to 6.02 times 10 to the 23rd, we can always divide by either side. So basically 1 mole over 6.02 times 10 to the 23rd equals 1. But 6.02 times 10 to the 23rd divided by 1 mole also equals 1. So since both of these things are equal to 1, it doesn't matter which one's on the top or on the bottom, and you can reverse it depending on which way you're trying to convert the units to. So it will make a little more sense as we do an example. So our first example here is 2.00 moles of nitrogen is equal to how many atoms? So we always want to start off by figuring out what is our given information. So what do they give us in the problem? So in this problem, they gave us that we have 2.00 moles of nitrogen. And then we want to figure out what we're trying to determine. And what we're trying to determine here is atoms. So what we are given is always what goes on the top of the fraction for our first set of parentheses. So 2.00 moles. We're going to put that over 1 just for spacing wise, is our first set of parentheses. Now, our second set of parentheses, the whole entire point of the second set of parentheses is so that we can cancel out the units from the first set of parentheses. So our first set of units that we had here was moles. And so if we have moles on the top, we want to make sure that it's on the bottom of the next set of parentheses because this will allow us to cancel it out. So that's the unit we're trying to cancel, and then the unit we're trying to make is atoms. So I'm going to put atoms on the top. So I always do my units before I fill in numbers, and this helps me to not make mistakes with multiplying when I should divide or the opposite. So atoms is going to be on the top of this one because that's what I'm solving for. Whatever unit you're trying to make should be on the top of your last set of parentheses. Whatever unit you're trying to cancel out should go on the bottom of the next set of parentheses. And if you have that set up correctly, then you can go ahead and fill in your numbers from your conversion factor. So our conversion factor is this guy here. So we can see that the number 1 is next to moles. So I'm going to put the number 1 next to moles in my conversion factor as well. Next to atoms, we have this big, ugly scientific notation number, which is 6.02 times 10 to the 23rd. So I'm going to put 6.02 times 10 to the 23rd. Now it's important to know that even though this is a big ugly number, it really is just a number. It's just a different type of notation to write a really, really, really big number with a bunch of zeros. So now we can go ahead and we can say, okay, I want to cancel out units. So I can cancel out moles, so I can cross those two off. And I'm left with atoms, which is good news because that's what the problem is looking for, which means that once we have the unit that we're looking for on the top of our last set of parentheses, that means that we can put in an equal sign and start actually figuring out the answer. So when you have multiple sets of parentheses, this is just a multiplication problem. And we want to go ahead and multiply the top things by the top things. So we're going to simplify this to be 2.00 times 6.02 times 10 to the 23rd. And remember that the units are very important. The units are the whole point of this. So atoms is going to go with that. Then the bottom stuff, the only thing we have left are the 2 1s. We don't have moles anymore. It got canceled. So this is just going to be 1 times 1. 1 times 1 is itself, so we can just kind of cancel that and not worry about it. So now, finally, we're just going to go ahead and simplify 2.00 times 6.02 times 10 to the 23rd atoms. So even though this is an ugly problem, it's really just multiplication. So I'm going to go ahead and I'm going to slide over to my calculator. And I just Googled for scientific calculator and this came up and it works perfectly. So what's the hardest part of this problem is knowing how to actually put this in the calculator. But it's simpler than you think. You're just going to put 6.02 and then instead of times 10 to the, you use this EXP key. And it'll give you a capital E, and that capital E means times 10 to the. Then you just put the power, which is 23. And this is a multiplication problem, so we're going to go times 2.00, and we hit the equal sign, and it gives us an answer. So this answer says 1.204, then this lowercase e. Don't let it bother you that this is a lowercase e when it was a capital before. It means the same thing. It just means that this is, the answer is the base is 1.204, and then the e counts as times 10 to the, and then the power is 24. So we would write our answer as this equals 1.204 times 10 to the 24th power. And what's our unit? Atoms. And that is our answer. So I'm going to go ahead and I'm only going to do one of each type of problem that I film here, or else this video would be super long. So I'm going to skip a little bit here and get to our next example. So the next type of example we have is volume of a gas. So when we do the volume of the gas, we're going to use a different conversion factor. For this, we're going to say that 1 mole is equal to 22.4 liters of any gas at STP. So STP is just this set of conditions. It stands for standard temperature and pressure. We'll learn a lot more about that later, but for today, just sort of believe me that 1 mole is equal to 22.4 liters. We'll worry about what happens if it's not at STP later. That's not for today to worry about. So same thing as what we were doing before. You always just look and you think, what is my given information and what am I solving for? So the given information here is 1.25 moles, and what we're solving for is liters. So as always, I'm going to take my given information and I'm going to put it over 1. So I'm going to go 1.25 moles over 1. And that's my first set of parentheses. My second set of parentheses, we want to have the unit we're trying to cancel out on the bottom. So whatever unit you had at the top is going to go on the bottom. So I'm going to put moles. And then whatever unit you're trying to make is going to go on the top. And so this is going to be liters. Then once I have my units in the right places in their parentheses, then I'm going to go back and I'm going to look at my conversion factor to fill in my numbers. So next to moles, I have 1. So next to moles, I'm going to put 1. Next to liters, I have 22.4. So next to liters, I'm going to put 22.4. Now I can cancel my moles, and I'm left with the unit that I was trying to solve for. So I can simplify this. This is going to be 1.25 times 22.4 liters divided by 1 times 1, so we can cancel those out. So 1.25 times 22.4, if we put it in a calculator, gives us 28 liters. So one more example. This time we're going to see what happens when we are doing mass with grams. So this time I'm actually going to work the second example for this one, so that you can see it a little bit differently. So in any case, the conversion that we use when we're trying to convert between moles and grams is that 1 mole is equal to the mass in grams from the periodic table. So actually, maybe I'll just do both of them for you. So you can see that we have 2 different elements here. So the first element we have here is helium. So the first thing we want to do when we're trying to do a conversion that involves mass is we have to look up the element on the periodic table. For the previous 2 examples, it didn't matter what the substance was because those conversions are constants and that are the same for every element or compound. In this case, though, it does matter. So we need to look up helium on the periodic table. So I'm going to go look at my periodic table here, and I'm going to find helium is located right here. And the mass of helium is 4.00. So I'm going to go ahead and write that down right now. That 4.00 grams of helium is equal to 1 mole. So now this is going to be the conversion that I use for helium, but it's specific to the element. So I start always, as always, with my given information, and I always have to establish what am I trying to figure out. So I'm going to start off with 2.1 moles of helium on the top of my parentheses. That's my first set of parentheses. Then my second set of parentheses, as always, I want to cancel out the unit from the first one and make the unit that the problem is asking for. So moles is going to go on the bottom, and grams is going to go on the top. So once I have those sort of set up in the right places, then I look at this conversion here and I fill things in where they go. So I have grams. The number next to grams is 4.00, and that's specific to helium. Remember, we got that number from the periodic table. So I'm going to go 4.00 grams, and the number next to moles is 1. So now I can cancel my moles out. I'm left with grams, which is what I'm looking for. So I can simplify this to be 2.1 times 4.00 grams divided by 1 times 1. Those are going to cancel just as 1. So 2.1 times 4 is going to be 8.4 grams, and the substance is helium, because remember, the substance matters when we're talking about grams. So last one, I'm going to do the same process and figure out how many moles are in 500 grams of aluminum. But remember, the aluminum is a different element than helium was, so I can't just use this same conversion factor. I have to look at the periodic table and figure out what the mass of aluminum is. And so I'm going to go over here, and I'm going to find my friend aluminum, who's located right here. Aluminum has a mass of 26.98. And so I'm going to come back and I'm going to say that 26.98 grams of aluminum equals 1 mole. So that's the conversion I'm going to use. So I want to go ahead again and look and say, okay, what is my given information? I have 500 grams of aluminum to start, and I'm trying to figure out the moles. So I'm going to set up my first set of parentheses with 500 grams of aluminum over 1. And then I'm going to set up my second set of parentheses to cancel out the units from the first set. So my units in the first set are grams of aluminum. So grams is going to go on the bottom. And then what am I trying to find out? I'm trying to find moles, right? So moles is going to go on the top. Then I look at my conversion here from my information from the periodic table. And I can see that the number next to grams is 26.98. Grams is on the bottom though, so I have to write 26.98 on the bottom because that's where that unit is. Moles has a 1, so I'm going to put a 1 next to moles. And now I can cancel out my grams. And I have moles as my unit in my last set of parentheses, and that's what I'm looking for, which means I'm ready to simplify and solve this problem. So 500 times 1 is going to be 500, and the unit is moles, divided by, remember that every fraction is really just a division problem, right? Divided by 1 times 26.98 is 26.98. So now I have 500 divided by 26.98. So I'm going to go back to my good old friend, the calculator. 500 divided by 26.98. And what do I get? I get 18. I'm going to round it off to 5.3. We'll learn about how to round for science a little bit better next semester. But for right now, we're just going to call it 18.53 and call it a day. 18.53. And then what is my unit again? Moles. So that is the answer. And hopefully this helped you guys to understand how to do these calculations a little bit better. So thank you very much, and I'll